Abdulrahman. That was the first name. Yep, it's like that. Abdulrahman. Yeah. No? Okay. Ahmed. Brian. Sabina. Faisal. Emiliano. Ting. Yon Huang. Lin Yuan. Nelson. Zhu Wei. Teodoro. Christian.
Yeah.
You said Christian?
Christian Guzman.
Yeah.
Oh.
Kelsey.
Yeah.
Christine. That's you guys.
Yeah.
Yeah. Christian and Kristen. Okay. Tasnim.
Yeah.
Darren. Andrew. Sharia. Shura. Michelle.
Yeah.
Yufeng. Davide. Davide. Casey. Mohammed Mola.
Yeah.
Nazifa. Yan.
Yeah.
Na.
Yeah.
Samuel. Shoshana.
Yeah.
Carolis.
Right.
Manpreet. Sana.
Yeah.
Bishoy.
Yes.
Yitzhak.
Yeah.
Rakaya. Did anyone not hear their name? Okay, so that was an awkward waste of time. Let's start over. I got off on the wrong foot. Allow me to reintroduce myself. My name is Javon Smith, and this is Calculus 3. Hopefully you're where you're supposed to be. So the first order of business, we're going to go through this syllabus because you need to know what's required of you. And I am going to actually hold you to everything that is written in this document. So you should actually read what we're going to be held accountable for. Yes, so my name is Javon Smith. You can call me Javon, is fine. You don't have to be like Professor or Mr. Smith or anything like that. Javon is fine. That is my email that you will use to contact me in for the class. Office hours are by appointment, and that is the website. That's actually a very important website. We're going to talk more about that. The textbook for this course is Stewart's Essential Calculus, the second edition. Does everyone have the second edition? Access to the second. Does everyone have the first edition? First edition? Okay. Well, I actually browsed through the textbooks. It seems that the problems aren't that different, so we could probably use the same problem sets for both textbooks. If I realize differently as the semester goes on, I'll give you an updated problem list because I have all the homework here prepared for you already. But as far as I know, that the problems are actually quite similar in the book. They've changed the numbers sometimes. Instead of x, they'll put a y. Instead of 2, they'll put a 3. But for the most part, the problem seems to coincide, so that'll do fine. So if you have the first edition, it's not the end of the world. You can probably get by with it. And we'll actually talk about how to get the second edition in a bit. The notes for MATLAB, you saw where to find those today, so here's where to get them again. Actually put the web link. That's the location of the math department website, and in particular, the Math 203 website, which we're going to be using often for practice problems. So yeah, so here I'm talking about why I gave you these websites and explain the importance of each one. So my website, I'm going to be posting documents there for the class all the time. So the syllabus is going to be posted there. It wasn't posted yet, but if I give you quizzes, the answers to the quizzes I'll post on that website. The solutions to tests I'll post on that website. And review problems for tests I'll post on the website, right? So there's a lot of information I'm going to be posting on my website, the one that ends with John Smith. Right? So it's going to be a good resource for you. And a lot of times I'm going to refer you to the Math 203 website because I'll have you practice problems from past final exams. And you can actually find past final exams on the math department and on the Math 203 website. Calculator. There are some problems in the textbook where you sort of need a calculator. They'll have that little icon. You'll have some problems where there's going to be like an icon that looks like this, right? Where it sort of means, you know, you should use a calculator to do it. In general, in class or in quizzes or tests, calculators aren't allowed. So you should really know the process of doing something and know how to do something without a calculator, right? You only use a calculator if they give you like weird numbers. But in general, in a quiz or a test, I'll give you nice enough numbers for you to work with, so you won't need a calculator. Grades are assigned according to the following chart, and I'm telling you their GPAs, right? So that's going to be, if your term grade is within any of these range, I'll give you that letter grade, and that's the GPA you'll get as a result. According to math department policy, finals are worth 40% of your grade. I have no say in that. I have to make it 40% of your grade. But the other 60, I can do what I want with it. So I actually broke the course down into several components, and that's how much percentage of your grade each part is worth. Quizzes. I'm going to be doing a lot of quizzes. I said 1 quiz per week in general. That should probably be 2. I mean, we are in the summer, so we have to sort of catch up. Homeworks. I'm going to be assigning homeworks regularly. Every time we finish a section, the homework for that section is due the next class. And so on participation, I'm pretty much going to take attendance every day, and your attendance grade is sort of going to be your participation grade. So I'm actually giving you credit to show up, right, which is really nice, and it's something you should do anyway. There's the percentage for MATLAB assignments and the exam, and in-class tests are 30%. The plan is to give you 4 exams, and I'll drop the worst 1, so really 3 will count towards your grade. And for homeworks, I'll drop the worst 2, so the rest will count towards your grade. And the final exam is 40%, and so that's how it's going to be, your grade is going to be broken down. The next paragraph, I just made some comments about the kind of students I think you are. So if you're in 203, odds are you're like an engineering major or one of the science majors like math or chemistry. Those are, chances are, in either of those cases, I mean, you need to be good at this stuff. You need to be good at calc2. So it's really important for you to do well, so it's not the kind of course you're just going to want to, you know, and take willy-nilly and say, oh, I'll just try to pass it. No, you really need to be good at this stuff, because what comes ahead is going to depend a lot on it. In particular, if you're in engineering, you're going to have to do a math course called 392, which is linear algebra and vector calculus for engineers. And that course is like 2/3 calc2. It relies really heavily on calc2. If you have a very solid knowledge of calc2, that course will be easy. If you don't have a solid knowledge of calc2, that course will be a nightmare. So it's really important for you to get this course. And in fact, if there are engineering majors in here, and I would highly recommend that you do 392 like in the fall, like right away. Don't let time between calc2 and that course pass you by, because there's a lot of calc2 in 392. You also have to do 391. You don't have to do them in order. You can take 392 before 391, so don't let the numbers fool you. I highly recommend you do 392 right after calc2 if you're an engineering student and you have to do it. Yeah, so you have to do well. Notice for credit, no makeup exams. I dropped some exams and I dropped some homeworks to, you know, just in case you're absent. Attendance, I expect you to be here all the time, and I'm actually going to grade you for it. Okay, let's go on to more expectations. Work ethic. You are not to slack off, and this is even more true in the summer. I mean, we're cramming 4 months into 8 weeks, right? So you miss a day of class here, it's like missing a week of class. You cannot slack off. You can't let it get ahead of you. You really have to be working every day. I'm not going to lie to you, it's going to be intense. It's going to be really rough. Just so you know, it's going to be a lot of work for this class, so I hope like none of you have full-time jobs or God forbid you're taking another class or anything like that, because a lot of time is going to go into this. I'm telling you now, just so you know, a lot of work. I'm not even exaggerating. Okay, so I expect very strong work ethic. You're going to have to put hours in every day to really get this. It's going to go by fast. It's going to be a lot of information coming at you. We have class every day for like 2.5 hours. Your brain will probably shut down after the first hour. Just, like I'm being real. So the way you actually combat that is you actually want to try to read ahead. It turns out that it's really funny. If you go to a math class and you've never seen the information before, and I'm just here, eventually it's going to be like I'm talking gibberish, you're just copying down notes and you don't know what's going on, right? That's how it is. But you'll realize that if you actually read through what I'm going to teach like the night before, and your brain is already starting to work on it, you'll find that you actually don't get mentally fatigued as easily or as quickly. You'll be able to keep up with the class, which is another thing about work ethic. I do expect you to work hard. In fact, I expect you to try to get ahead of me as much as possible, because it's going to help you, and it's going to make your class time more beneficial, and it will actually help with that mental fatigue that will obviously going to set in a 2.5-hour class. So that you should be aware of. Homework, like I said, I'll assign homework. Pretty much every day you're going to get homework. Every time we finish the section, you're going to do homework. I don't know if we're going to finish the section today, but after today, every day you'll be getting homework. And every time I complete a section, the homework for that section is due. And it's due at the beginning of the next class, because then I'm going to actually go over some of the homework problems. Anything you guys have trouble with, we're going to actually go over it to make sure that we fill in any gaps that need to be filled in. So try to do your homeworks promptly. Late homework assignments are not accepted. So be sure to complete your homework as quickly as possible and know where your weaknesses are so you can come to class the next day and ask me if you have trouble. But I expect you to actually attempt and complete most of the problems for homework. There really should be only like 1 or 2 problems that might give you a lot of trouble in the homework. When you hand in homework, I expect you to hand it in a certain format. I give 5 stipulations on how I expect your homework to look when you hand it in. Show all your work. If you only write the answers, I'll just assume you looked in the back of the book and wrote the answer. Right? I'm not going to assume you actually worked it out. So show all your work. If anything can be written down, write it down. It has to be stapled if your homework consists of more than 1 page. So if you hand in pages to me and sort of just bend the corners or not even attempt to do that, you're actually going to lose points for it. It must also be properly labeled. Make sure you have your name and your section number and your topic number. Let me make sure I know what those, make sure you guys know what those are. So on the 3rd page, this is a list of the homework problems for the entire semester. So you can actually go ahead and do other homework now if you wanted to. The topic number is the number in the leftmost column, right? And the section number is the number right here on the section, right? And these are the problems you should do in that section, right? So if you're handing in homework, I expect the top should look something like the name. Then you can say topic 1, or you can say homework 1, either one. Then you say section 10.1, and then you can start the problem, blah, 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 right? But I expect the heading of your homework to be like this. I expect it to be stapled if it consists of several pages. I expect it to show all your work. I also expect, so you know what I expect, only one homework per stapled group. So it might be the case, it will definitely be the case, that sometimes I'm going to actually cover more than one section. So let's say in tomorrow's class I finish 10.1, 10.2, and 10.3. I'm just throwing those out there. I might actually finish those, but I don't know. I expect you to actually keep these separate, right? So 10.1 homework, you staple those, that's 1. 10.2 homework, staple those separately, that's 2. 10.3 homework, staple those separately, that's 3. Right? Only one topic number per stapled group, and make sure you write neatly. That's the last thing. Okay. Previous coursework. Math is cumulative if you haven't realized it by now. Every time you do a certain math class, it depends on the math class you did before it. And Calc 3 is no different. You're going to have to remember your Calc 1 and your Calc 2 in order to be good at this course. You're going to have to remember pre-calc also to be good at this course. And algebra obviously falls into that. So pretty much every math you've done before this, I expect you to remember. You're going to need to remember or else you're going to struggle. It's just how things are. So we're sort of going to be doing the same things you've always been doing in calculus, you know, derivatives and integrals and applications, but we're going to be doing them in different contexts. So you really have to be comfortable with, you know, the basics to be able to do these things very efficiently. And so I do expect you to remember pretty much everything you've done before. So make sure you're all experts at that. And now we have the mantra for the class. Something I expect you to repeat to yourself 10 times a day. I will not cancel across sums. Does anyone know what cancel across sums means? Something like this, right? So if I have like 2x plus 5 divided by 2, and then you do something like this, and say that's x plus 5. You cannot cancel. Why can't you cancel? There's a sum. There's a plus sign, right? There's a plus or a minus sign between two terms. You cannot cancel across those terms. If you do that, it's a very serious offense, right? So I will not cancel across sums. I will also not distribute powers across sums. And what does that mean? If you see something like this, a plus b squared, and then you do something like this, that's you thinking that you can just take the power and distribute it across the sum, which is actually not true, right? This is not true. So I don't expect to see anything like that. So I will not cancel across sums, I will not distribute powers across sums. I will not divide by 0, which, yes, people have tried to do before. So some people think that, you know, 2 over 0 is actually equal to infinity, or 2 over 0 is equal to 0, all sorts of stuff I've seen. Crazy. Division by 0 does not make any mathematical sense. Don't do it. And if you do anything like that, I will be very upset. Use brackets very appropriately. So if you have x plus 1 times x plus 2, I will not consider that the same as x plus 1 times x plus 2. They're actually not the same thing. Right? This one, only the 1 is multiplying the x plus 2. This one, the entire expression x plus 1 is multiplying the x plus 2, right? Do not write this when you mean that, right? Even if you think, oh yeah, I know what I meant. Trust me, it's going to end up bad for you, right? Because in the middle of a test, you're in the heat of the moment, you write things down sloppily, and you're looking back up to write something down in the next line. You're going to see this and you're going to do it wrong, right? I see mistakes with this all the time. So be careful, make sure you use your brackets properly. Don't do anything like cancel across a sum or distribute powers across a sum. This actually also includes radicals, right? So if you see the radical of a plus b, it is not the same as the radical of a plus the radical of b. It's the same as distributing a power across a sum, right? A radical is, what's the power of a radical? Right. What you actually did, if you do this, you're actually saying you can take the half, apply to the a, and apply to the b, and you can do that. It's actually not true. Not in general, right? One or both have to be 0 in order for this to be true. In general, it won't be true, right? So make sure you don't make any of those mistakes. And as an incentive, I'm giving you a reason not to make any of these mistakes. Because if you do make any of these mistakes, I'll give you 0. Not for the question, for the whole exam. You understand? Did you hear what I just said?
Yes.
Okay. If at any point in your exam you commit any one of these offenses, I give you 0 for the whole exam. I do not care what you write otherwise. Okay? That's your incentive. There are some mistakes that should not be made at this level. Those are such mistakes. Other mistakes that I do not expect you to make. I see things like this all the time. Not true, right? How do you actually do this? How do you do this integral? And what would that be? Which is?
X minus X plus C.
Okay, right. The integral of this is that, not this. A lot of people think that once you have 1 over something, it's just automatically ln. This is actually not true. It's only true for linear functions. If you have 1 over x dx, that is equal to lx. Or if you have something like 1 over ax plus b dx, that is equal to 1 over a ln of ax plus b plus c. There is no other form that will give you ln. It can only be these two forms. If you have a power on the x that's not 1, it's not ln. If I see you put that, very big mistake. And I mentioned that here. That's mistake number 1. Another mistake. I expect you to remember the product rule for integrals and derivatives. So, which for integrals is called integration by parts. So if you see something like this, it's not the same as you just integrate the f and then you multiply by the integral of the g. Right? So if you see so if I see a mistake like I say to integrate x sine x, and I see you write something like squared over 2 times, what's the integral of sine?
Negative cosine.
Negative cosine. Okay, so if I ask you to do this and I see you do something like that, big mistake. How do you actually integrate this?
The U
By
is
parts?
equal to X and then the like I think the dv.
Integration by parts, right? U equals x, dv equals sine x dx. Right? Your du would be dx, your v would be minus cosine x x, and then you do integral of u times v. It's u times v, right?
uv minus integral of v du.
Minus the integral of v times du. The negative here will make this a plus, so that's cosine x dx. And so this will be what? Right? That's how you actually integrate products, right? You do integration by parts if it applies. Doesn't always apply. Sometimes you have to use things like substitution. But at all costs, I do not expect you to do this. Try anything else. I will be a lot more lenient than if you do that. Right? Even if you don't remember this stuff. Okay. Those I'm actually a bit more lenient. I'll just give you 0 for the problem that we make them. Okay, so yeah, so very serious mistakes. I do not play around if you make them, so make sure you don't make them. Make sure you can recognize when one of these are happening and be like, no way I'm doing that, right? Because it is not worth it. Next thing, contact. I expect everyone to email me by the end of today. I need information like your class and its section. Email me from an email that you check regularly because I will be emailing you guys all the time. I'll actually be emailing report cards as we go on through the semester, so you can sort of see your current progress as you go on and make announcements and things like that. So I really need your feedback, and of course, I've learned that you always have to give kids incentives, so of course I'll deduct points if you don't do it. It's just how it works. Right, so emails are important. Make sure you email me. That's very important. That's why I put it in bold and I underlined it. So make sure you do that by the end of today. Feedback, in general, I encourage feedback. Right, so I'm not just here for a paycheck. I actually like math, and I actually want to teach well, and I want you guys to learn, and I want you all to follow me. So if there's something that is stopping you from being able to follow me, you should let me know. Right, give me feedback on my teaching and things like that. If you have any suggestions or anything you think will make the class run smoother, be better for you, you should let me know. Just make sure you have constructive criticism, and it's actually very helpful the way we do it, right? So don't just say things like, your teaching sucks, right? You should say, your teaching sucks because, you do this, you do that, you do that. I think it's better to do this. Okay? So just make sure it's constructive, it's fine. I won't grade you down, but in case you're suspicious, there's actually anonymous feedback thing on my website, the same website I gave you at the beginning. So you can always give me feedback. Let's talk about help, which is going to actually be very important during the summer, because like I said, it's going to be intense. You're not going to get a rest. It's going to be a lot of work. It's going to be a lot of information crammed in all at once, and odds are you're going to need help at some point. So I listed some resources here that would be very helpful to you. There's free math tutoring in the Marshak building, room 418S. That's on the fourth floor of the Marshak building. That's the science building, the tallest building on campus. The hours of operation this semester are Mondays through Thursdays, 12 to 5 p.m. So you can go there, and there will be tutors there that will help you with your calc203. I will also actually be there a lot of the times as well. And so you can even come here to see me if you want. And so you can get help at the tutoring center for calc203 during the semester, and it's free, and it starts tomorrow, I believe, is when they open. So that's that. Also on the Math 203 website, there are actually video lectures. There's a professor here, Dr. Marchese, who she runs hybrid courses. So she has like an online component to a course, and then there's a lecture component, and they sort of mash them together. And so she'll, her lectures, they sort of look like how Khan Academy does it, right? You just see what she's writing down. But they're like video lectures of everything, like the whole course, right? So you can actually see, you can actually watch the whole course online. So, I think each video is like half an hour or something like that. So I think it's actually a really nice way to get ahead. So, like just watch a half an hour video the night before class, and you'll know what I talk about. And again, it will help your brain to be nimble and not be as fatigued as easily. So yeah, that's pretty cool. So she has videos for calc203, and they're on the math department website, on the calc203 page. There's websites like mathhelpforum.com. I used to help out there a lot. I don't really anymore because I don't have time. But you can go there and you can get your questions answered at various hours of the night. Of course, there's everything, right? Technology has made it so easy to get help nowadays, like YouTube, Khan Academy. There are tons of things, resources online. Google, how do you do this? You'll find something. So it's really great. Wolfram Alpha is a great site. So in Wolfram Alpha, has anyone here actually used Wolfram Alpha before?
I did.
Yeah, it's a pretty neat site, right? You can actually just like type stuff in, and it will give you the answer, and it will like plot a graph or something like that. So you could actually, if you want to say compute the integral, say 0 to 1 of x sine x dx. Right, you can literally just type in Wolfram something like int of x sine x dx x from 0 to 1. You can type that in the thing. It will actually do the integral for you and tell you the answer. so you can check your answer. So if you, I assign odd problems usually for homework, so the answer is in the back of the book, but what if you want to practice even problems, right? How do you know how to check your answer? Go to this website, type it in, right? So there might be some issues with the syntax, but I think you guys will be able to sort of figure out how it will understand you. Right? So it's a really great site, and not only will it compute things, it will probably like give you a graph and tell you, you know, what the integral you're computing means and things like that. So it's a really nice site. Another resource is your classmates. So you should get the contact information of somebody, just in case in this class they can give you the lowdown. And you might have noticed I'm actually also video recording the lectures. So I'll be posting videos on YouTube, and I'll send you guys the link. So if you miss a class, you can actually see specifically what happened in your class. So I thought that would be cool. Yeah, and there's always me. Right? So I know I scared you guys with this thing. I'm going to give you 0, but I'm actually quite approachable. I'm not really mean. I just think that there are certain mistakes that you shouldn't make, right? And it'll make you better math students to know you should avoid these things. Class rules and the usual academic integrity. Don't cheat, right? If I catch you, you'll be in trouble. Again, after that, you have the list of all problems for the homework and the tests where they fall, right? So I don't have the dates for the tests. I just know that once I complete this set of topics, I test you on that set of topics, right? Then I do this. Each test is not cumulative, right? So test 1 only covers topics 1 through 7. Test 2 will only cover 9 through 16, and so on and so forth. Except where, you know, you have necessary overlaps. But in general, they're not cumulative. The final is cumulative, which is on, it will be on July 22nd, I think. But the time and the room to be announced. Yeah, these problem sets are actually from the first edition, which I didn't really see a need, from just browsing through both textbooks, I didn't really see a need to update the problem sets, but if I noticed I would need to do that.
Is the first edition the red book?
Yeah.
And, okay.
And the second edition, it's white and blue on the spine, and the front, there's a red square in it.
Okay.
Yeah. It's weird. It's like a picture of the cover of the first edition on the page of the second edition with a border. Yeah. Okay. Right. MATLAB assignments, as you see here, I assign those as we go along. Right. So every time we do a MATLAB, I'll tell you a bunch of problems I want you to do, and of course how I want you to hand that to me. Also remember, your first assignment is to contact me according to what I asked for. I put the academic calendar also in your syllabus. It's good for you to know what dates are important. Right? Like the day when classes begin, yay. And when W periods begin, when you can get refunds, you know, deadline for degree audits, and et cetera, et cetera. And this is the course learning outcomes. Basically, this is what we expect you to learn by the time you complete a Calc 3 course. Some of the basic requirements that I have to give this to you because you're accredited and I'm required by law to give this to you. So, basically, you should know everything in the syllabus. That's what we're going to do. This is sort of like some course analysis. I also have questionnaire at the back. It is anonymous. I'd like you to fill them out so I know what kind of students I'm dealing with. Right? So things like your major and where you want to go, what you want to do, how your confidence as far as math is concerned. Dates that you might miss exams for because of religious reasons, things like that. You should let me know about them now. Yeah, so take a few minutes to just fill out those questionnaire, and then you can just attach them and then pass them up. Okay, so I don't know if it makes sense to actually start a chapter. So yeah, remember what I said about remembering all the math you've done before. Let's talk about that. What's that?
An integral.
Integration by parts.
Okay, what's the answer?
One of
No. Yeah, you're right. 1 over x or something like that. I take out more points than the problem's worth. The derivative of ln x is 1 over x, right? What's that? No.
x.
Integration by parts, you would be.
X ln absolute x.
You would be ln du, dv would be dx, and by this point you should actually have this
X
memorized.
ln
X ln x
x.
minus x plus c.
But it's
That's something you should have memorized.
absolute x.
No, not absolute. Something you should have memorized. Right? It's not 1 over x. That's a mistake I see all the time, and I'm very harsh when someone makes that mistake. What about this one? You're taking too long. Huh? Arctan. Okay. How would you do that?
Trig substitution.
What would you substitute?
4 minus x squared.
X for 2 sine theta.
So you want to do a trig sub. Is that what you're telling me?
Yes.
You could also do
You could also do a trig sub. Which one is easier in general? U sub is easier, right? I mean, there's a hierarchy of things, you know. You try to do one of the basic rules. If that doesn't work, try substitution. If that doesn't work, try integration by part. Right, in general, U substitution is easier than trig substitution. You wouldn't want to do that. So yeah, you'd let U equals 4 minus x squared. Or better yet, you can actually let U squared equals 4 minus x squared. Right?
Mm-hmm.
Did you guys ever do that? Actually makes your life a lot easier to actually do a U squared substitution sometimes. So now what you can do is you have 2u du is equal to minus 2x dx. So you just have u du equals minus x dx. Or minus du equals x dx. Right? And what you realize here is you have that x dx. So your integral just becomes 3 times minus u du divided by the radical of this, but u is the radical of that, so that's just u. Right? So that integral becomes minus 3 du. Right? And so that would be what?
-3 plus c.
What? Negative 3u plus c. This is minus 3. U is actually the radical of 4 minus x squared plus c, right? Or, probably a more standard way, but you're going to have to work a little bit harder, is to let u equals 4 minus x squared. Your du is equal to minus 2x dx, and so you have minus a half du is equal to x dx, and so your integral would be, put minus a half out here, you still have that 3 here, and under here you'd have what? You'd actually have radical, right? So it's a little bit more messy than that, right? Actually doing a U squared substitution to get rid of radicals altogether actually makes your life a lot easier, but if you don't mind working hard, you could also do this. So it's minus 3 over 2. This you think of as u to the minus 1/2. And so how do you integrate that? U to the 1/2, because minus a half plus 1 is 1/2, divided by 1/2, which is the same as multiplying by 2. So So the 2's cancel, and you just have minus 3 times u to the 1/2 plus c, which we know that your u was actually 4 minus x equals 3. Right? Which is the same answer, but slightly a little bit more work. Right? So that's sort of a trick that you guys can use to make things simpler. Yeah, if you have a radical, just get rid of it. Substitute a square instead. Right? What I'm actually doing is I'm letting u be the entire radical. Makes your life a little bit easier. Let's see, what else can I see? What's sine of pi over 6? You're taking too long. What's sine of pi over 6?
Wait, no, 1/2. Yeah.
Okay, sine of pi over 6 is 1/2. What's cosine of pi over 4?
No, under 2 over 2.
What's tan inverse of 1? No. What's sine of 0? What's sine of 5 pi?
Is it 0?
What's sine of 7 pi? What's cosine of 4 pi?
1.
What's cosine of 7 pi?
Negative 1.
What's cosine of pi over 2?
0.
What's tangent of pi over 2?
1.
It doesn't exist. Right. Why doesn't it exist? Because tangent is sine over cosine, and cosine of pi over 2 is 0, and we cannot divide by 0, so it does not exist. Okay, let's see. How would I find the area between the curves y equals 2x squared and y equals 1 minus x squared? Yeah?
First, you have to find out the points of intersection.
Okay, how do you do that?
You said the two equations equal to one another.
Okay, what do you write?
So 2x squared equals 1 minus x squared. Rearrange the equations so that you have everything on the same side.
So x would be plus or minus 1 over radical 3, right? Now what?
So that's our limit.
What?
That's the mean.
That's your 2 points of intersection.
Okay, so what do we do next?
Oh, you have to see which function is greater than the other on that interval.
Okay, how do you check that?
Well, they're both parabolas, that's one thing.
Yeah, for one, could you draw a picture?
Plug in x equals 0, plug in x equals negative.
Right, you can plug in x equals 0 into both. You realize this gives you 1, that gives you 0, so this is higher. And
Add x equals
you could
0.
also just graph them, 1 minus x squared, you know, 2 looks like this. So this is y equals 2x squared. This guy is y equals 1 minus x squared. Clearly the 1 minus x squared is on top in this region. We just found these intersections minus 1 over radical 3. This intersection is 1 over radical 3. And so the area is going to be equal to what?
Negative
1 minus x squared.
Right.
So this will be 1 minus 3x squared dx. Is there something I can do to make my life a little easier?
Yes, because the area is symmetric with respect to the y-axis, you can just do twice the integral from 0 to 1 over root 3.
That is correct. I could also do that. That'll actually give me the same answer because we have symmetry. And so I don't have to plug in both plus and minus 1 over radical 3. I can just plug in 0 for 1, which is a lot easier to work with. And I assume you guys can do the rest of that. What does a derivative tell you?
It changes something with respect to time.
Is it always time?
Sometimes position at the same time.
Rate of change of anything, right? Rate of change of something with respect to something else. You just have to define what these variables are. So if I give you a function f of x, tell me some facts about f prime of x. What can I use f prime of x to do?
Find minimum and maximum.
You can find maximums and minimums using the first derivative. What else can you do?
You can also determine if the function is increasing or decreasing,
How do you know it's increasing?
if the derivative is greater than 0.
Okay. How would you find a max or a min?
And the derivative is equal to 0.
Is that the only time?
No. And it's also undefined.
When it's also undefined, but the function itself is continuous, right? So it's what we're talking about are critical points, which is where the derivative is 0 or undefined. So if I look at this guy, the second derivative, what does that tell me?
Concavity.
Concavity. What else can I get from the second derivative? Points of inflection. How can I find a point of inflection?
When concavity changes.
Concavity 0.
When the concavity is 0?
But it also changes from concave up to concave down.
How do I know if it changes from concave up to concave down?
If the second derivative is negative and then becomes positive, or positive and then becomes negative.
0 or undefined.
Yeah, technically. That because undefined would deal with cases where you have like sharp corners and things like that. Yeah. Okay, let's see what else you know about calc203. You guys know how to do that? What is that? It's tangent. What about this?
We use the
What would the parts be?
one and
Secant squared x and secant.
Right, you lose this as secant squared x times secant. This would be your dv, that would be your u.
Can you use
Can we
trig identity?
convert the secant square x?
You can use a trig identity now.
Yeah, we could use the trig identity.
For what?
We could convert
no.
this.
No, I'm moving on now. We're not talking. Yeah, that's annoying. So that, you know, that's another one where they actually in Calc 2 a lot actually. So you should also have that one memorized. Let's see, what else can we talk about? First two things that come up.
Pythagorean theorem.
Pythagoras' theorem. What else?
Trig substitution.
Trig substitution. Is the first thing that comes here.
Second. First thing is always.
Huh?
The special triangle.
Special triangles. Something more basic.
Right angle.
Trigonometry.
SOHCAHTOA, right? You see a right triangle, you think Pythagoras' theorem and SOHCAHTOA, right? We're going basic here. You always start with the simpler ideas first and you build them up. What does that look like?
It's squiggly. It's a squiggle.
It's a squiggle. It's a squiggle. That is a mathematically precise description of that function.
It's like two curves.
It's a semicircle.
Is that a semicircle? Is that a semicircle?
That's massive.
Hmm?
Oh, is that a hyperbole? No.
Well, I mean, yeah, I'm not asking what the curve is. I mean, yeah, if I told you y equals the radical of 1 plus x squared, is that a semicircle?
No, it's a line that goes off to infinity.
How do you know it's not a semicircle?
That was
Because square Root.
You can square both sides. Y squared is equal to 1 plus x squared, which means you can bring the x squared. You have y squared minus x squared equals 1. That minus messes it up. It's not a circle. What kind of curve is that? It's a hyperbola. How would you graph it?
Like the curve, but like on the opposite side. It's the ellipse, but like break it and turn it on the other side.
Like that? Yes? No?
Yes.
No, it's like this. Okay, but how would I do that integral? How would you do a u substitution on that?
Yeah, you get 2x.
You can't do a u substitution. How would you do it? What do you substitute? What do you substitute? Anyway, like I've been saying, it's very, very, very important for you to be aware of the math that you've done before. What's cosine 7 pi over 6? You're taking too long. How do you remember the sine and cosine of the special angles? Huh? What's your mnemonic? How do you remember them? And like, if you forget them, what do you do? Just like, I can't answer the question, you just give up?
You randomly plug them in.
You would draw a unit circle
Yeah.
to figure out sine of 7 pi over 6.
Well, yeah, I know it's the same thing as sine. Pi over 6.
Sine of 7 pi over 6 is not exactly the same as sine of pi over 6. What are the so-called special angles? 30, 45, 60 degrees, right? Which in radians is what?
Pi over
Pi over 6 is 30 degrees. Right. The way I like to remember is just draw a table, which is really easy to fill out. Count up from 1 to 3. Backwards cosine. Okay, the radical of everyone. Then divide everyone by 2. And you have all these things. You don't have to draw a triangle or anything. You just see. So now sine of pi over 6 I know is a half. Cosine pi over 4 I know is r equals 3 over 2. All that stuff from the table, but it's pretty easy to figure out. Now if I ask you about sine of 7 pi over 6, what do you do? Figure out which quadrant it's in. How do we figure that out?
In the third quadrant?
It's in the third quadrant, right? We have pi over 6 here, which means I take pi, divide into 6 pieces, pi over 6, right? You can do that here. And you pretty much count all 7 pieces, right? 1, 2, 3, 4, 5, 6, 7 brings you in the third quadrant. What does that tell you? Negative. How do you know it's negative?
because sine is
All students take crap or calculus or whatever. Okay? So now you know that whatever the answer here, it's going to be the negative of the special angle. This is just minus sine of pi over 6, which from your table you know is just a half. See, if you don't know these things off the top of your head, you have to be able to come up with them really quickly because you're going to be doing all this stuff I'm showing you. Calc 3 are doing this in the background, okay? You're going to need to be really quick with it and really very flexible. You need to remember everything you've done before. Because you're doing Calc 3, you're not only doing Calc 3, you're doing it in the summer. Which means you're either like a masochist or I don't know. highly motivated or something like that. But it's going to, like I said, it's going to be rough, and you are going to need to know everything from your previous math classes. But maybe there's no point in me saying that, because I mean, no one here would actually try to register for calc203 in the summer, not remember all the math before, right? That's just plain no irresponsible. And you guys look like a bunch of responsible kids. Which is why I have a test for you.
You have a
Yep.
test?
First quiz of the semester is today. Put away your stuff.